All right, y'all, so we're going to get in 9.7. And that deals with applications. And really what we're going to look at is what we call models for growth and decay. So we're going to look at growth and decay models. So tonight's homework will be using these formulas, okay? So I'm going to give you the exponential growth function. All right, so the exponential growth can be given by this formula. And then I'll explain what everything is. So P of T, all right, y'all, let me let one in real quick. P of T is going to equal P subscript O times E to the exponent K times T. So let me explain what this is. Now, they're using P because a lot of times the growth function, you use that with populations. So they're using P, which would stand for the population, how the population would grow. So P of T stands for population at any time T. So that's the population at any time T. That P subscript O, that stands for our initial population. Okay, E, that's that Euler's number we looked at before. K, the K is what we call the growth rate. So that's the growth rate. And then T, of course, stands for time. Okay. So if they ask for the exponential growth function, they're wanting us to get this kind of formula. Okay. Now, if this was for decay, exponential decay, so the decay function is really similar to this one. The only difference is decay is negative. Okay, so it'll be P of T equals your initial population times E to the negative K T. Okay, so that'd be what we call the decay rate instead of the growth rate. Okay. You might use this one when you're talking about finding the half-life of radioactive material. A country's population might be declining over time. So you represent it with a decay function, okay? All right, so y'all, I'm gonna give you a couple more formulas based off of this one. Sometimes they'll want us to find K. So to find K from these formulas, to find K, K will equal the ln of your PT divided by your P initial, all of that divided by the time. So if they want me to find the growth rate or the decay rate, I use this formula. I take the ln of the ending population divided by the initial population. Once I get that answer, I divide by the time. Now, sometimes they might look at how long does it take a population to grow to a certain amount. So in that case, they would be wanting us to find T, which is time. So to find the time on these formulas, so let me see my chat. I see a chat coming up. Yeah, so ln is the natural logs on these. Good job. So good question. So yeah, when you see this ln, y'all, that's I'm using a small ln, but that definitely stands for natural log. All right, so the T is really similar to this formula. T will equal the ln of the PT divided by our P initial, all divided by our K. All right, now another exponential growth that y'all seen here recently was COVID. And y'all remember them talking about doubling time and some of them fun words? So we actually got formula for what we call the double time. So this is the double time, which is basically the amount of time it takes for the population to double. So that formula, we use a capital T to represent double time, and that'll equal the ln of 2 divided by RK. And then my last one, the last formula I'm going to show you is finding K by using the double time. So finding K using double time. That one would be K equals the ln of 2 divided by the doubling time. Okay, so little t means time, capital T means doubling time. So y'all, this page of formulas is what we're about to use for our next few examples. Okay, so let's start with question number 1. So this one says, in the year 2012, the population of a city was 5.31 million. So population, 5.31 million. The experimental growth rate, so the growth rate was 2.49% per year. So they got a 4-part question here. A, they want us to find the exponential growth function. So we're going to find the exponential growth function. So basically, they want us to figure out what formula we would use so that at any time t, we could find how our population grew. B, they want us to estimate the population in the year 2018. C, they want to know when will the population be 9 million. And then finally, y'all, D, they want to find the doubling time. So y'all, let's start with A. They want me to find the exponential growth function. So we know that the function will look like P of T equals P of O, which is my initial population, times E to the K times T. So we want to be able to plug in for the T and get these populations at that time t. So our formula will be P of t equals, so y'all, what was my initial population they gave me? That was, what was that? 5.31 million. So we're going to replace P initial with 5.31. Then we got our E. Now they gave me K. K we said was 2.49%. But we need to turn that 2.49% into a decimal before I can put it into this formula. So to turn 2.49% into a decimal, you need to move that decimal left twice. So since I'm moving it twice, I'm going to have to add a 0. So I get 0.0249. So that's the same effect as dividing by that 100, okay? So my K was 0.0249, and then I bring in my T. So for Math Lab, it's going to have the P of T already. All we do is put in our 5.31 E to the exponent 0.0249 T. So now if you give me any year, I can figure out the time and then get that population. All right, B wants me to estimate the population in 2018. So what we got to do is figure out how much time passed from that initial population to 2018. So y'all, we ended up in 2018. My initial population started in 2012. So 2018 minus 2012 gives me 6 years. So now we're going to plug 6 in for our T and get the population in 2018. So we're finding P of 6. Okay, so that'll be 5.31 times E 0.0249 times 6. So y'all, I'll go to the calculator and punch that up real quick. So let me share my calculator screen. All right, so we had 5.31. Since my E has an exponent, I'm going to hit the second LN button to bring up the E with the exponent. And then my exponent was 0.0249 times 6. So I'm just going to use my parentheses to multiply. All right, y'all, now listen, on this one, they want us to round this 1 decimal place. So let's hit enter. So I'm getting 6.1, but since the 1 has a 6 behind it, I'm going to round that to 6.2. There you go. So perfect. So we'll go with, that's going to give us 6.2. Now the Math Lab will write the million here. So all you got to do is actually put in the 6.2. So these are problems I always sort of had fun doing these because you're working with formulas. All right, C said, when will the population be 9 million? So on that one, I'm looking for how much time is passing before my population is 9 million. So y'all, for that one, since I'm looking for time, my time is going to equal the LN of my PT divided by my PO, all that divided by RK. All right, so let's write our LN. My PT is going to be the ending population. Well, the ending population will be the 9 million. So we'll put in a 9 on top, divide that by my initial population, which was when we started, it was 5.31. I'll take that answer and divide by my K, which was 0.0249. All right, so let me show you how I would punch that one in. And y'all, on this one, they want us to round 1 decimal place. So we're finding how many years after 2012 it took for my population to get to 9 million. So let's go punch that in. So now remember, I hit the LN first, and then I had 9 divided by 5.31. So the LN is taking the LN of that quotient. And then once I get that answer, I'm going to divide that all by my K, which was 0.0249. All right, y'all remember we're rounding this 1 decimal place. All perfect. 21.2 looks good because I'm going to round that one up. So we got what? 21.2. So what that means, it took about 20 years for the population to grow almost 4 million for that one, okay? So Math Lab will say it took 21.2 years after 2012, okay? All right, D said find the doubling time. So y'all, I'm going to use the formula where capital T doubling time equals the ln of 2 divided by my K. So here we go. The top's going to be ln of 2. Our K was 0.0249. All right, so let's see what you got on that one. So round me 1 decimal place. And tell me how many years it takes this to be doubled. So I'm going to go punch mine on my little calculator real quick and see what I get. All right, so we had what? The ln of 2. Those are parentheses. And then divide by 0.0249. So let's see, we need to get what, a 27.8, y'all saying? So there you go, that 3 is small, so that's going to stay 27.8. So what that means, y'all, is it takes almost 28 years for my population to go from 5.31 to, what double be, 10.62, okay? So y'all, not too bad. Keep that page of formulas I gave you, okay? All right, so the next example, like y'all's number 2. This one wants us to complete the table. So we're going to complete the table. So in my table, we're going to have a population. And we're looking at country A and country B. Next column will be the growth rate, which is our K. And then the last column will be the doubling time, which is our capital T. Now, in the growth rate, they gave me country A was 1.9% per year. They didn't give me country B's doubling growth rate, so we'll have to find country B's growth rate. Now, country A, they didn't give me its doubling time, so they left that blank. But they gave me country B's doubling time, which was 43 years. But y'all, remember my doubling time formula, doubling time equal to ln of 2 divided by K. And our K equaled to ln of 2 divided by our doubling time. So we need these two formulas to fill out these two boxes here. So y'all, I'm going to find the doubling time for country A first. So this will be country A. Its doubling time is going to equal ln of 2 divided by its k. But remember, you can't put 1.9% in here. You got to turn that 1.9% into a decimal. So move that decimal left twice, and that'll make a 0.019. All right, y'all, so let's punch that in and see what we get. All right, so where did I go? All right, here we go. All right, so I had an ln of 2, those parentheses, divided by 0.019. And let's see, let's hit enter. Now the doubling time, they want rounded to the nearest year. So no decimal places. So that's 36.48. I'm going to call that a 36. So we'll go 36 on our doubling time. So that'd be 36 years. Now you don't have to write the years. They've already got that wrote to the side. All right, y'all. Now we're going to find country B's growth rate. So we know K equals the ln of 2 divided by its doubling time, which was 43 years. Now this one, round growth rate to the nearest tenth, so they want one decimal place. So let's go see what is a ln of 2 divided by 43. And we're going to go one decimal place. Now notice they're giving me 0.016. So let's go back and I'm going to show you how they want that. Now notice in the answers, they're writing them as percents. So what you got to do is turn this decimal back into a percent. And to turn it into a percent, you move the decimal back to the right 2 spots and add the percent. So that'll give you a 1.6%. So we'll come in here, put the 1.6. MathLab already has the little percent to the side for you. All right, y'all. So if you got to get tattoos of these formulas, that's cool. Okay. Oh, this thing. I'm going to go to my next one to be like y'all's number 4. 3 is sort of like number 1, so I'm going to skip it and go to 4. So on 4, they gave me a table. And the table has years and then married adults. So let's see, it goes from 1960, 1980, 2000, 2010, and then they do 2012. The married couples, the percent who were married was 68.6, 56.4, 51.4, 47.6, and 40.6. So for they want this to be, this is going to be like a, let's see, looks like it's got 3 parts. So for A, they want me to find K. And they want me to use the data, using the data for 1960 and 2012. Okay, so remember, I gave you a formula to find K. K. Now notice I don't have doubling time, so I won't be using that formula. I'm going to use the other formula where K equaled the ln of my PT divided by my P initial all over RT. So we're going to fill in for this. ln. My PT will be the ending percent of married adults. So that'll be in 2012. And it said 40.6. So we'll have 40.6 on top divided by my initial percent of married adults, which was 1960. And they had 68.6. All that divided by our T. So T is the number of years from 2012 to 1960. So let's see, that'd be what, 40 and 12, so 52 years. So down on the bottom, we're going to divide that by 52. Now think about this. The percent of married adults was higher in the beginning than it was in the end. So our K should end up being negative when we do this because we got a decline, okay? So I'm just going to pop my calculator up on the screen here. Let me grab my other one. Instead of switching back and forth, okay? Now, on this one, we're going to round our K to 4 decimal places. So y'all, here we go. We got ln of 40.6 divided by 68.6. Close those parentheses and then divide that answer by 52. So remember, we're rounding 4 decimal places. And you see that is negative like we said. So in here you get negative 0.01. Let's see. Oh, and then my 4th decimal place has an 8 behind it. So I'm going to make that a 0101. Now listen. Although our K is negative, when you put the answer in MathLab, they assume that the negative is in the formula. So all they want you to do when you put that in is put the 0.0101. You do not have to put the negative because they're assuming the negative is already in that formula, okay? All right, then they just wanted to write the exponential function for this. So they're using M of T. M stands for the married adults. Our initial amount was the 68.6. E, at this point, you would put your negative 0.0101. So you do have to use that negative when you're writing it in the formula, okay? And then that'll be times T. So if I know how many years have passed, I can figure out the amount or the percent of married adults. All right, y'all, let me see. Part B, so I'm going to have to go to another sheet here. So part B for that one wants me to estimate the percent of married adults in 2015 and 2018. So here we go, 2015. Well, we got to figure out how many years passed from 1960 till 2015. So we take our 2015 minus our 1960. That gives me 55 years. So we're finding the percent after 55 years. Oh, y'all, my bad. I'm so used to using P's, but remember, this one is M. They're using the M for marriage, okay? So my initial amount we said a while ago was 68.6 e to the negative 0.0101, and t was 55. So we'll punch that on the calculator, y'all, and we're going to round this one 1 decimal place. Now, we expect it to be lower than 68.6 because we got a negative k here, okay? So, y'all, here we go, 68.6. Second ln to get the e, negative 0.0101 times 55. So, hit enter, round me 1 decimal place. That looks like 39.36. So, I'll make that, what, a 39.4. Okay, so now we had 2018. But remember, that's just 3 more years. So we'll be finding M of 58. So y'all, same formula, just put a 58 in for the T. 68.6 times E, negative 0.0101 times 58. Now that's 3 years after that, so it better be lower than 39.4, okay? So here you go, 68.6. Second ln for my E, negative 0.0101 times 58. All right, y'all, round me 1 decimal place. That will be 38.2. So in 3 years, it almost dropped, it dropped over 1% in just 3 years there, okay? All right, so check this out. At this decay rate, in which year will the percent of married adults be 30%? All right, so I'm going to see. All right, so we got to find out how much time passes to reach 30%. So remember, to find my T, I'm going to do my ln of my PT divided by my P initial, all divided by RK. So here we go, ln. Well, my PT, all right, let me get mine plugged in. My battery is running low. So my PT is going to be the 30%. So we got our 30. Our initial, what was our initial? 68.6. All that divided by my K, which was a negative 0.0101. This will give me the amount of years. I can add that to my 1960. and we'll find out what year this will happen. So y'all, here we go. LN, 30 divided by 68.6, close parentheses, divide by negative 0.0101. Y'all, we're going to round this to the nearest whole number. So that's going to be what, 81 rounded to the nearest whole dollar. That's an 8, so that'll be an 82. So the time it took was 82 years. So you got to do 1960 plus 82 to get what year that happens. So here we go. 1960 plus 82 means the year 2042. Okay. All right, y'all. So I'm going to do a couple more on here. It probably be a shorter lesson tonight, but it's just learning these formulas here. So let me do one like number 5 for y'all. So let me get my paper situated. So the number of farms in a certain state has declined continually since 1950. So in 1950, there were 81,242 farms. 1995, that number decreased to 22,107 farms. So assuming the number of farms is decreasing according to the exponential model, find the value of K and write an exponential function that describes the number of farms after T years. So what we got to find is our K. And guess what? We got enough to find K because we know how many years passed from 50 to 95. We got our beginning amount and the ending amount. So here we go. K is going to equal to ln of our PT divided by our P initial, all divided by the T. All right. The final number of farms was 22,107. Divided by the initial amount, which was 81,242. We'll take that answer and divide by time. So y'all, from 1950 to 1995, what's that? 45 years. All right. They're rounding my K off to 3 decimal places on this one, okay? So y'all, let's see what we get. We got our LN, 22,107 divided by 81,242, those parentheses, and divide by 45 years. All right, remember, I'm going 3 decimal places. So let's see, that'll be where the 8 is. So it looks like I'm going to be turning my 8 into a 9. So I'm going to get a negative 0.029. And so let me show you on that one. They would give you 4 answers. And all we got to do is find the one that had the negative 0.029. And then it automatically gives you its equation. Okay, so we'll just put C on that one and be done. Hey, also, let's see what we do on this last one. There are currently 55 million cars in a certain country, decreasing by 1.7% annually. How many years will it take for the country to have 30 million cars? So how many years until only 30 million cars? We're going to round this one to the nearest year. So they just want to know how many years it's taken. So remember, I'm looking for the time on this one. So I would use the other formula. Time equals the ln of my PT divided by my P initial, all divided by my K. All right, so that's going to be our ln. Our ending amount will be the 30 they want, divided by my current amount or my starting amount, which was 55 million. Take that answer and divide by K. But y'all remember, I can't use 1.7% in my formula. So what would y'all turn 1.7% into as a decimal? Oh, I'm not hearing no people. Is that mute? All right, 0.017. There you go. Oh, good job. You just moved it twice and got my answer I needed. So, who wants to try that formula and see how many years it takes to go from 55 million cars down to 30? And y'all round me to the nearest year when y'all work it. Oh, so where's my brave ones at? Oh, you are like so close. What's bugging you is that decimal you got. So let's punch this in again. Because you are really close. I think you must have missed a decimal somewhere. So you did your ln 30 divided by 55. Those parentheses, and then divide by the 0.017. So you should. Oh, you know what messing this up, don't you? Remember, this is a decline, right? So they're saying it's decreasing, so RK has to be negative, remember? So now punch in a negative 0.017. Oh, I almost forgot it said decreasing, so we have to make our K negative. So the ln of 30 divided by 55 divided by negative 0.017. Now you actually get what, 35.7. Actually round that to the nearest year. No decimals. So no decimals, what would you put? You make that what? 36 even. Okay, so watch out if they want the nearest year, they don't want decimals after those. So the good job, you're learning to punch that on that calculator, right? All right, so y'all, here's how it is. Using them formulas I gave you, you should be able to breeze through this homework tonight. Get that knocked out. Like I said, next Tuesday, we're reviewing for test 4. Next Thursday, we're going to start reviewing. We should be able to get through the whole final exam review. But if we don't, I will finish that up on Tuesday, May 3rd. Final exams will open up May 4th, and your final exam will be due Sunday night, May the 8th. So remember, all work in Math Lab has to be done by May 8th. It's going to shut you down at that point, okay? All right, any questions on this lesson tonight, y'all? All right, so I'm going to stop our recording and give me a few hours. I'll send this out. Y'all have a good weekend, and I'll see y'all Tuesday.